Hello everyone, welcome to this class on finite element analysis, and in this class let's learn this derivation of Hermite shape function for a beam. So this is a very important derivation which is asked many times in the exams. So you can just see, so the description of this derivation will be: consider a beam with two nodes 1 and 2, and this is described in natural coordinates. Natural coordinates means where you will be writing the zeta. So this is nothing but zeta, that is so if you consider the natural coordinates, zeta means when the origin will always be at the center, so therefore zeta will be equal to 0 at the center. Suppose if it goes to the left hand side, zeta will be -1, to the right hand side, zeta will be +1, and at each node there will be two displacements for a beam element. Therefore q1 is considered as vertical displacement at node 1, q2 is considered as angular displacement or slope at node 1. Similarly, q3 is considered vertical displacement at node 2, as well as q4 is considered angular displacement at node 2. So that itself we can write as a description, that is, consider a beam element with two nodes 1 and 2 in natural coordinates. Let q1 and q2 be the displacements at node 1 respectively, and q3 and q4 be the displacements at node 2 respectively. Well, q1 and q3 are nothing but the vertical displacements at node 1 and node 2, while q2 and q4 are nothing but the angular displacements at node 1 and node 2 respectively. So now I'll just write this. So let that itself be the description. Therefore you can just write at node 1, q1 is the vertical deflection or the vertical displacement. You can just take like vertical displacement or vertical deflection, while q2 is nothing but the angular deflection or angular displacement, or you can just in simple words you can also call it as slope. So you can call it as a slope. Similarly, q1 and q3 and at node 1 and node 2, that is. Similarly, q2 and q4, it's going to be like that. So here we are going to derive this Hermite shape functions. So Hermite shape function is denoted by h. So therefore at node 1 there will be Hermite shape function h1 and h1 dash. Similarly at node 1 for q2 you will have h2 and h2 dash. Similarly for at q3 you will have h3 and h3 dash, and similarly for q4 you will have h4 and h4 dash. And we are going to derive this h1, h2, h3, h4. I'll tell you what is that h1 dash, h2 dash, h3 dash and h4 dash. They are nothing but the angular deflections or angular displacements or the slopes. So h1 dash, h2 dash, h3 dash, h4 dash are nothing but the angular displacements. Now you have to know one thing: the shape function at the corresponding node is always equal to unity. Unity means it is 1, meaning the shape function at corresponding node will always be equal to 1. Now you see, when I derive the shape function h1, I have to find out what is the values of that h1 dash at node 1 and node 2. Just like that I have to do for h2, h3 and h4. Now first let me write shape function h1, that is Hermite shape function h1, Hermite shape function h1. Now let's try to know its values at node 1. So at node 1, what is the value of h1, and also at node 1 what is the value of h1 dash? So that one you have to know, and also you have to know what is the value of zeta. Okay, so the value of zeta is clear here. At node 1, the value, this is node 1, this is node 2, this is at the mid node or something. So the node 1 and node 2, the value of zeta at node 1 is -1. So what is the value of h1 and h1 dash? You see, h1 is nothing but the shape function because of this vertical displacements, while h2 dash is the shape function because of this angular displacement. Similarly, h3 is the shape function because of vertical displacement. h4 dash is the shape function because of angular displacement. Therefore h1, h2 dash, h3 and h4 dash, that is going to be 1 at the corresponding nodes. For example, at node 1 you have h1 and h2 dash that is equal to 1, while h1 will be equal to 1, while h1 dash will be equal to 0, because h1 dash is not equal to 1. Okay, at node 1 you have only h1 and h2 dash, not h1 dash, h1 and h2 dash. Similarly at node 2 you have h3 and h4 dash. Therefore this is going to be 1. So now this Hermite shape function is given in the form of a cubic equation, that is given by a plus b zeta plus c zeta square plus d zeta cube. This is how you're going to write it. Now just let's try to substitute those values, but before substituting, let me also try to find out the value of h1 dash. H1 dash is nothing but dh1 by d zeta. So trying to differentiate this equation with respect to zeta, I'm going to get b plus 2c zeta plus 3d zeta square. That is doing differentiation for this. A will be 0, b and zeta, b I'm going to take it outside, and zeta differentiation is 1, and zeta square differentiation is 2 zeta, and c I'm going to write it as it is. Zeta cube differentiation is 3 zeta square, and d I'm going to write it as it is. So this is nothing but h1 and h1 dash. Now let me try to substitute these values into this equation. So what I'm going to get, so first h1 is going to be equal to 1 at zeta is minus 1. So here in both the cases zeta will be equal to minus 1. That is very, very important. Let me try to scratch it out. At both the situations, or h1 and h1 dash, zeta will be equal to minus 1. Therefore 1 equal to a plus b into minus 1 plus c into, in this equation I'm going to substitute, c into minus 1 the whole square plus d into minus 1 the whole cube. So let me try to utilize this space. So therefore I'm going to get 1 equal to a, b into minus 1 is minus b, minus 1 the whole square is going to be plus 1, plus 1 into c is going to be plus c, and minus 1 the whole cube is going to be minus 1 again, it is going to be minus d. It is going to be a minus b plus c minus d. Now let me try to substitute these values. 0 into this equation, into second equation, 0 equal to b plus 2c into minus 1, because zeta is minus 1, plus 3d into minus 1 the whole square. So suppose if I substitute that, I'm going to get b plus into minus is minus, minus 2d. Here it's going to be minus 1 the whole square, that is nothing but plus 1, and that's going to be plus 3d. So this is going to be equation number 1, and this is going to be equation number 2. Now at node 2, what are the values are going to be? At node 2, I have to find out the value of h1, and also have to find out the value of h1 dash. But the value of zeta at node 1, at node 2, the value of zeta is going to be plus 1. It is clearly mentioned in the question itself. In the figure itself, it's clear that at node 2, the value of zeta is plus 1. At node 1, the value of zeta is minus 1. Here it's mentioned node 1 and node 2. So it's clearly mentioned. Okay. So value of zeta is plus 1 at both the nodes. While h1 and h1 dash, you can clearly see at node 2, there is only h3 and h3 dash, h4 and h4 dash. There is no h1 and h1 dash. So directly let's put it 0. We don't have that at all. So h1 is going to be 0 and zeta is plus 1. h1 dash 0, zeta is plus 1. So trying to substitute that into this equation, equation that is h1 and h1 dash, we are going to get both as 0. 0 equal to a plus b into 1 plus c into 1 square plus d into 1 cube. So it is going to be like that. Therefore, I'm going to write it as 0 equal to a plus b plus c plus d. It is going to be like that. I'm going to take that as equation number 3. Now let's try to substitute that value of h1 dash over here. So if I try to substitute into this equation, I'm going to get 0 equal to b plus 2c into 1. That is 0, and zeta values will be plus 1 here. So 0 equal to b plus 2c into plus 1 plus 3d into 1 square. Therefore, I'm going to get b equal to 2b plus 2c plus 3d. So let me take it as equation number 4. So now I have all those 4 equations. So the first equation, so let me try to write this one into the left hand side now. A minus b plus c minus d, that is equation, that is equal to 1. That is nothing but equation number 1. And equation number 2 is nothing but this one, b minus 2c plus 3d equal to 0. That is equation number 2. And equation number 3 is going to be this, a plus b plus c plus d, which is equal to 0. And equation number 4 is this, b plus 2c plus 3d, which is equal to 0, which is nothing but equation number 4. So now what I have to do is I have to add this equation 1 and 3, and I have to subtract this equation 2 and 4. So let me try to do that here. So adding equation 1 and 3, what I'm going to get? So adding equation 1 and 3. So you just see it clearly. So let me try to write that once clearly. A minus b plus c minus d. So let me try to write that left hand side again. So plus this one, a plus b plus c plus d, a plus b plus c plus d. That is equal to, so which is equal to 1 plus 0, 1 plus 0. So let me write that 1 plus 0. So here you can see a plus a will be 2a, and minus b plus b gets cancelled. C plus c will be equal to 2c, and minus d plus d will also get cancelled. That is nothing but equal to 1. Or I'll just take 2 as common. I'll get a plus c, which is equal to 1. So 2 into a plus c is equal to 1. Or also I can write a plus c equal to, if the 2 goes to the other side, is going to be a plus c equal to half. That's what I've got. So now let me try to subtract that. So let me try to write those two equations again. So if I try to write those two equations, it is nothing but b. So that is, I'm just going to do equation 2 minus equation 4. So equation 2 is b minus 2c plus 3d. b minus 2c plus 3d minus equation number 4. Equation number 4 is nothing but b plus 2c plus 3d. b plus 2c plus 3d. This is what I've got here. So this is nothing but equation 2 minus equation 4. So both are equal to what? Both are equal to 0. So therefore 0 minus 0 is going to be 0 again. So b minus 2c plus 3d. So this minus b, minus I'm going to multiply it inside. So I'm going to get minus 3d, that is equal to 0. So here plus 3d minus 3d gets cancelled, plus b minus b gets cancelled. I'm going to get minus 2c minus 2c is minus 4c, which is equal to 0. So if I send this 4 to the other side, it's going to be 0, c equal to minus 0 by 4, which is nothing but 0. Therefore I'm getting c value is 0. So the value of c remains to be 0. Now let's try to substitute the values of c here into this equation. Into this equation, if I try to substitute, for example, into the equation here you have something like a plus c equal to half. If I try to substitute that here, I'm going to get like this. That is a plus c equal to half. If I try to substitute this value, I'm going to get a plus 0 equal to half, or a equal to half. So I've got the values of a as half. So a value is half and c value is 0. So now let's try to substitute values of a and c in equations 1 and 2. So what do we get? So equations 1 and 2. So equation 1 is nothing but a minus b plus c minus d equal to 1. a minus b plus c minus d. That is nothing but a minus b plus c minus d equal to 1. So that implies, so a value is half minus b plus c is 0 minus d equal to 1. So if I just send this half to the other side, or else if I try to bring that, so something, let me try to send this minus b minus d to the other side, and let me bring this 1 to this left hand side. I'm going to get half minus 1, which is equal to b plus d, or minus half is nothing but b plus d, or I'm going to get it like this. So minus half is b plus d, so I'm going to get it like this. Or else next what I'm going to do is, this is equation 1, which implies like that. Now let me try to see what happens if equation 2, if I try to substitute the values of a and c. Equation 2 is here b minus 2c plus 3d. b minus 2c plus 3d equal to 0. That implies b value is, let's try to b value only, minus plus 3d, b plus 3d equal to 0, because c value is 0. So b plus 3d equal to 0, or b equal to minus 3d. So let's try to substitute this value over here. So what do I get? Therefore minus half equal to, in place of b I'm going to write it minus 3d plus d. Therefore minus half, I'm going to get minus 3d plus d is nothing but minus 2d. Minus and minus gets cancelled. D equal to, if this 2 comes to this side, I'm going to get d equal to 1 by 4. So now I've got the values of A, I've got the values of C, and I've got the values of D. Now let me try to get the value of B. So here you have B equal to minus 3D. Therefore B equal to minus 3 into, substitute this value over here. I'm get 3 into 1 by 4. I'm going to get minus 3 by 4. So therefore the values of A is nothing but half, B is nothing but minus 3 by 4, C is nothing but 0, and D is nothing but 1 by 4. So this is the final values whatever I have got. So let me try to substitute all those values into the Hermite shape function h1. So let me try to do that. So h1 you have a plus b zeta plus c zeta square plus d zeta cube. A plus b zeta. So h1 you are having a plus b zeta. So let me try to write that, a plus b zeta plus c zeta square plus d zeta cube. So let me try to substitute all those values. A is half, b is minus 3 by 4, c is 0, and d is 1 by 4. I think it's correct. A is half, b is minus 3 by 4, c is 0, and d is 1 by 4. So let me try to substitute all those values here. I'm going to get h1 equal to, only those a, b, c, d values I'm going to substitute. Half plus B is minus 3 by 4 zeta, and C value is going to be 0. It's going to be 0 zeta square plus 1 by 4 zeta cube. So let me try to substitute that. I'm going to get half minus 3 by 4 into zeta plus 0 zeta square is 0 plus 1 by 4 zeta cube. So this is going to be h1. So now what I'm going to do, I'm going to take 1 by 4 common into this. If I take 1 by 4 common, what is going to remain here? It is not, you have to understand it very simple, in a simple way. So 1 by 4, when I take common, 1 by 4 into something, some number is going to give me this half, correct, right? 1 by 4 into that sum, into some number only. When I take it, if I take 1 by 4 common, 1 by 4 into some number only, I'm going to get this half. So therefore 1 by 4 into that x, let that x be some number equal to half. Let that x be, if this 4 goes to the other side, it's going to be 4 by 2. 4 by 2 is nothing but 2. Therefore 2. So 2 ones and 2 twos are nothing but 1 by 2. So you can just clearly understand here. And similarly, 1 by 4 into some number, I'm going to get it 3 by 4 here. You can just see clearly. Therefore, if this 4 goes to the other side, I'm going to get 4 into 3 by 4. 4 gets cancelled. X is going to be 3 there. So minus 3. Therefore, minus 3 by 4 is minus 3 by 4. I have written here. And 1 by 4, if I take it common, I'm going to get zeta cube. So here I'm going to retain that zeta over here. So this is nothing but the final value of h1. So in a similar way, we are going to solve the values of h2, h3 and h4. So similarly at node 2, at for example shape function h2. So shape function h2 at node 1 and 2, we have to write the boundary condition. So that is very, very important. So shape function h2, it is nothing but at node 1, and at node 2. So at node 1 and node 2, we have to find out the values of h2 and h2 dash and zeta. And similarly at node 2, we have to find out the values of h2, h2 dash and zeta. So the values of zeta is going to be plus 1. So at both the at node 1 it's going to be minus 1, and at node 2 it's going to be plus 1. So you can clearly see here at node 1 it is minus 1, and at node 2 it is plus 1. And you can just see what is the value of h2 dash. That is, at node 1 h1 is the vertical displacement and h2 dash is the vertical displacement. Therefore at node 1 h2 will be 0, h2 dash is going to be 1. h1, h2 dash, h3, h4 dash at corresponding nodes is going to be 1. Apart from that, all other will be 0. And at node 2, you can see directly there is no h2 and h2 dash at all. So directly that is going to be 0 at node 2. So at node 2, the values of h2 and h2 dash is going to be 0 directly, while the values of h2 dash is going to be 1 here for shape function h2, and this is going to be 0. So now h2 dash is nothing but dou h2 by dou zeta. That's what it's going to be. So once you substitute all these values, for example, the value of h2 is going to be a plus b zeta plus c zeta square plus d zeta cube. This is going to be the equation. And similarly, when you try to differentiate that, you're going to get b plus 2c zeta plus 3d zeta square. This is what is going to be the values. So once you substitute all these values, you're going to get, so let me try to write that quickly. So you can just see clearly, I have just substituted all this. So for example, whenever you try to substitute these values into h2 dash is going to be 1. That's why here it's going to be 1. This is because this is h2 dash. And all other things will be 0. It is same as whatever you got it in for h1, for shape function h1. The left hand side is going to be the same. Only the right hand side, these values are going to change. Because of that, the values of a, b, c, d is going to change. Only this right hand side values are going to change. And because of that, that values of a, b, c, d, all that it's going to change. Again, you have to add equation 1 and 3. And again, you have to subtract equation 2 and 4. So adding equation 1 and 3, what do I get? So 1 and 3, a plus a will be, so you can just write it similarly however I did it for this first h1 shape function. So as the time consumption will be very huge, so let me try to tell it directly to you. A plus a is going to be 2a, and minus b plus b is going to get cancelled. C plus c is going to be 2c, and minus d plus d is going to get cancelled, and 0 plus 0 is going to be 0. That is nothing but going to be a plus 1 plus 3. 2 minus 4, let me try to do that again. So b minus b is going to be 0, minus 2c is going to be minus 4c, and 3d minus 3d is going to be 0. 1 minus 0 is going to be 1 again. So it's going to be like this. Therefore, you're going to get the value of c as, so this minus 4 goes to the other side. I'm going to get minus 1 by 4. So 1 by minus 4 is what I'm going to get. That can be written as minus 1 by 4. So here let me try to substitute this. So this equation implies I can just take 2 as common. A plus c, I'm going to get it as 0. So if a plus c is 0, if this 2 goes to the other side, I'm going to get a plus c as 0. If a plus c is 0, a will be equal to minus c. Already I've got the value of minus c. Already I've got the value of c, that is it's minus 1 by 4. So therefore minus into minus is going to be plus. A value is going to be plus 1 by 4. So a value is going to be plus 1 by 4 and c value is going to be minus 1 by 4. So a value is plus 1 by 4 and c value is minus 1 by 4. So now let me substitute those values into these two equations. So what do I going to get? Equation 1 implies, so I'm getting in equation 1, it is a minus b plus c minus d equal to 0. So it is nothing but clear a minus b plus c minus d. It's clear here, directly you can just see here a minus b plus c minus d. So a minus b plus c minus d is 0 and a plus b plus and b minus 2c plus 3d. So therefore the values of a is 1 by 4, value of a is 1 by 4 minus b, value of c is minus 1 by 4 minus 1 by 4 minus d equal to 0. So this is also going to get cancelled directly. I'm going to get only minus b minus d equal to 0, or minus b will be equal to plus d. Or I can say b equal to minus d. Anything I can just say. Both are going to be the same. So now let me see what does equation 2 implies. Equation 2 is directly, you can just see from the question itself. So a minus b plus c minus d, that is going to be equal to 0. That's what we saw. So 1 by 4 and minus 1 by 4 got cancelled. B minus 2c plus 3d. B minus 2c plus 3d. So here we have b minus 2c plus 3d equal to 1. So we have that directly. So if b is minus d, let me try to substitute that b as minus d here. Minus d into minus 2 into value of c is minus 1 by 4 plus 3d. 3d equal to 1. So minus d plus 2 by 4, because minus into minus is going to be plus 3d equal to 1. So this is going to be half. So 3d minus d is going to be 2d. 2d equals to 1. If this half goes to the other side, is going to be minus half. So 2d is going to be half, or d equals to, this 2 goes to the other side, it's going to be 1 by 4. So finally we have got the value of d. If d is that, b value is going to be minus of minus 1 by 4. Minus of plus 1 by 4. So it's going to be minus 1 by 4. Therefore, the value of a is 1 by 4. Value of b is minus 1 by 4. Value of c is, so c value we have got it as minus 1 by 4. And d value we have got it as 1 by 4. So I've got all the 4 values. So now let me try to substitute those values here. H2 equal to a plus b zeta plus c zeta square plus d zeta cube. So let me try to substitute that here. I'm going to get H2 equals to 1 by 4 minus 1 by 4 into zeta minus 1 by 4 into zeta square plus 1 by 4 into zeta cube. That is what I'm going to get. Let me try to take 1 by 4 common. I'm going to get 1 minus zeta square plus zeta cube. That is nothing but the shape function H2. So I believe you have understood that. So now similar way we have to derive the H3 and H4. Okay, now for shape function H3, let's try to find out the values of zeta at node 1 and node 2. And also let's try to find out for shape function 3, in the sense we have to find out the values of H3 and H3 dash at node 1, H3 and H3 dash at node 2. So you can see the values of zeta. You can just see clearly from this figure, values of zeta is minus 1 at node 1, zeta is plus 1 at node 2. Therefore, it's going to be minus 1 here and plus 1 here. So that's clear. It's clearly shown that it's minus 1 and plus 1. So value of H3 and H3 dash. You can see directly at node 1 there is no H3 and H3 dash at all. It's all about H1 and H2, H2 and like H2 dash and H1 dash. So directly the values of H3 is going to be 0 at node 1 and H3 dash is also going to be 0 at node 1. H3 indicates the vertical displacement. Therefore, I have told you beginning itself. So the corresponding shape function of the corresponding node is going to be equal to unity. H1, H2 dash, H3, H4 dash. H1 is for vertical displacement Q1, H2 dash is for angular displacement Q2, H3 is for vertical displacement Q3, H4 dash is for angular displacement Q4. Therefore, H3 and H4 dash are going to be equal to 1. So now here we are speaking about H3. So H3 at node 2 is going to be 1 and H3 dash at node 2 is going to be at node 2 is going to be 0. Now let's try to substitute all those equations into this equation, that is H3 equal to A plus B zeta plus C zeta square plus D zeta cube. So let's try to substitute all those into this equation and see what happens. So this is the equations what are we going to get upon applying the boundary conditions, that is H3 dash zeta zeta 1 all that. So when you substitute all these boundary conditions, we are going to get, so when you substitute all these boundary conditions into this equation, we are going to get this one. So the values are going to be 0 0 and 1 and 0. So when you substitute, you can understand it easily. This is something but going to be H3 and H3 dash at node 1. At node 1 both are 0. This is H3 and H3 dash at node 2. So this is for node 2 and this is for node 1. So this is for node 1, this is for node 2, H3. So now similarly, this is going to be equation 1, this is going to be equation 2, this is going to be equation 3, and this is going to be equation 4. So let me, upon adding equation 1 and 3, what I'm going to get, upon subtracting equation 2 and 4, what I'm going to get. Let me just try to write that. Okay, so upon adding, so I'm going to get a plus a as 2a, c plus c as 2c, minus b plus b is going to get cancelled, minus d plus d is going to get cancelled. I'll get 2a plus 2c as 1. Taking 2 common, a plus c, I'm going to get it like this 1. That is, I'm going to get it 2 here. So similarly, when I'm just bringing it here, I'm going to get a plus c as 1 by 2. Similarly, here b and b minus b, 3d minus 3d is going to get cancelled. I'm going to get minus 2c plus into minus minus. So minus 2c is going to be 0. So minus 2c is going to be minus 4c. Therefore, c value will be 0 divided by minus 4, which is nothing but 0. If c is 0, substituting that value over here, I'm going to get a plus 0 equal to half, or a equal to half. So the value of a is going to be half there. So now let's try to substitute the values of substituting values of a and c in equation number 1 and equation number 2. So upon substituting that, what I'm going to get, so equation 1 implies, so what I'm going to get, half minus b plus 0 minus d equal to 0. I'm going to get half equal to minus b minus d. If it goes to the other side, I'm going to get it plus b and plus d. Similarly, equation 2 implies, so b minus 2 into c is going to be 0 directly, plus 3d equal to 0, or I can put b equal to minus 3d. So substituting that b equal to minus 3d here, I'm going to get half equal to b minus 3d. So I'm going to get directly like this, or half equals to, okay, instead of not b minus 3d, so it is in place of b, I'm going to substitute it as minus 3d. So minus 3d plus d it is. So in place of b, I'm going to substitute minus 3d, d I'm going to retain it same. So minus 3d plus d is going to be minus 2d, or if I send this minus 2 to the other side, I'm going to get the value of d. D is minus 1 by 4. If d is minus 1 by 4, substituting that value over here, I'm going to get b equal to minus 3 into minus 1 by 4. I'm going to get 3 plus, minus into minus is plus. Therefore, the value of b is going to be 3 by 4. The value of b is going to be 3 by 4. The value of d is going to be minus 1 by 4, half and 0. Therefore, I'm going to get final values of a is half, b is 3 by 4, c is 0, and d is minus 1 by 4. So half, 3 by 4, 0 and minus 1 by 4. Half, 3 by 4. So half, a is half, b is half, b is 3 by 4, c is 0, and d is minus 1 by 4. So I believe that values are right. So d is minus 1 by 4. Yes, that's right. So now let's try to substitute that values in H3. H3 is nothing but a plus b zeta plus c zeta square plus d zeta cube. That is what is going to be the value. So now let's try to substitute that. H3 equals to a value is half plus b is 3 by 4 zeta plus c, it's going to be 0 into that is going to be 0 directly, and d is minus 1 by 4 zeta cube. That is what it's going to be. So now H3 equals to half plus 3 by 4 zeta, plus into minus is minus zeta cube. That's what we get. So now let's try to take half common, sorry, 1 by 4 common. 1 by 4 if I take common, as I told earlier itself in H1, 1 by 4 into something is going to be that 1 by 2. Therefore, if I send that 4 to the other side, 4 by 2 is going to be 2. So 2 ones are 2 twos are, so it's going to be half. And here it's going to be 3 zeta, so 3 by 4 and minus zeta cube. So this is going to be H3. So if you have any doubts in taking the common here, you can just go back to the video and try to find. So check it out in H1. So in H1, I've just shown you clearly how to find it. Now finally, you have shape function H4. So shape function H4. So let's try to find out that shape function H4. So the values of zeta at node 1 is going to be -1, zeta at node 2 is going to be +1 directly, and values of H4, you don't have anything like H4 and H4 dash at node 1. You can just see clearly there is nothing like H4 and H4 dash at node 1. You have H4 dash equal to 1 at node 2, that's all. So therefore at node 1 it's going to be directly 0, and at node 2 H4 dash is going to be 1 and this is going to be 0. So upon substituting all these into this equation, that is H4 equal to a plus b zeta plus c zeta square plus d zeta cube. So let's see what are we going to get. So I've just written it over here, so just to reduce the total time duration of the video. So it's going to be 0 0 0 and 1 here. So this is going to be for node 1 and this is going to be for node 2. That is at node 1 H4 dash both are going to be 0. At node 2 H4 and H4 dash is going to be 1. So the left hand side is going to be the same. So it's going to be equation number 1, this is going to be equation number 2, this is going to be equation number 3, and this is going to be equation number 4. So adding equation 1 and 3, what do we get? So let's try to write that. Adding equation 1 and 3, it's going to be the same. 2a plus 2c is going to be equal to 0. Minus b plus b minus d plus d gets cancelled. So 2a plus 2c is 0 in the sense that I can just take a plus c, 2 as common, 0. If I send to this 2 to the other side, I'm going to get a plus c as 0 by 2, which is equal to 0, or I can write a equal to minus c. I can try to write like this, a equal to minus c. So now let me try to just do this 2 minus 4. 2 minus 4 when I do, I'm going to get b minus b 0, 3d minus 3d equal to 0, minus 2c as minus 4c. So minus 2c plus into minus is going to be minus. So 2 minus 4. So when I do equations 2 minus equation 4, I'm going to get minus 4c equal to 1, or if I send the c to the other side, I'm going to get c equals to, so the value of c is going to be, if this 4 goes to the other side, it's going to be minus 1 by 4. So the value of c is minus 1 by 4. So now let's try to substitute that over here. So you have already a equal to minus c over here. If a equal to minus c, so it's going to be directly minus of minus 1 by 4, which is going to be plus 1 by 4. So the value of a is plus 1 by 4. So the value of a is plus 1 by 4 and the value of c is minus 1 by 4. Now let's try to substitute all those values into this equation number 1, that is a minus b plus c minus d equal to 0. So equation 1 implies a minus b plus c minus d equal to 0. So in that, if I try to substitute, what I'm going to get minus 4 minus b minus 1 by 4 minus d equal to 0. So both are going to get cancelled. I'm going to get minus c minus d equal to 0, or minus b equal to plus d, or I can also write b equal to minus d. I'm going to get it like this. So now let's try to substitute. So if I just try to do that in equation number 2, so equation number 2 implies, so I'm going to get what I'm going to get in equation number 2, b minus 2c plus 3d equal to 0. So b minus 2c plus 3d equal to 0. So let's try to substitute all those. So in place of b, I'm going to write it minus d. So minus d plus minus 2 into minus 1 by 4, that is the value of c. C is minus 1 by 4 plus 3d equal to 0. So 3d minus d is going to be 2d. So minus into minus is going to be plus. 2 by 4, it's nothing but half. Half is going to be 0. So 2d is going to be minus half, or d equal to, if this 2 goes over here, it's going to be minus 1 by 4. So finally the values are nothing but a is 1 by 4, b values, if d is minus 1 by 4, so therefore b value is going to be minus of minus 1 by 4. So it's going to be b equals to plus 1 by 4. So that's what I'm going to get the value. So b is 1 by 4, c value is minus 1 by 4, and d value is also minus 1 by 4. So I'm getting all the 4 as like 1 by 4, 1 by 4, minus 1 by 4, and minus 1 by 4. So now let me try to substitute that. So let me try to substitute that into this equation. H4 equal to a plus b zeta plus c zeta square plus d zeta cube. So H4 is nothing but equal to 1 by 4 plus 1 by 4 into zeta plus minus 1 by 4 into zeta square minus 1 by 4 into zeta cube. So if I just substitute that and I'm going to take it as common, I'm going to get 1 plus zeta, so minus zeta square minus zeta cube. So this is what you're going to get the value of H4. So like this we are going to find out all the values H1, H2, H3 and H4. So you can just see here, after derivation we are going to get H1 value as 1 by 4 into 2 minus 3 zeta plus zeta cube. The value of H2 I have highlighted all. H2 is equal to 1 by 4 into 1 minus zeta square plus zeta cube. And the value of H3 value is going to be like I've just done it over here, 1 by 4 into 2 plus 3 zeta minus zeta cube. And the value of H4 value is nothing but 1 by 4 into 1 plus zeta minus zeta square minus zeta cube. So what you all have to learn is the boundary conditions correctly. So thank you so much for watching the video. Bye.